Hi, welcome to Week 7 lecture, Fundamentals of Digital Image Output. My name is Anne Verdaniger. In today's lecture, I will provide an overview to input processing workflow before then looking at some fundamental concepts related to image output. The lecture will include concepts of monitor calibration and working space, that is the space you're working in to complete your editing. To also look at concepts of color gamut, color space, before providing an overview of possible print output devices and their image preparation requirements. This semester, I introduced you to the idea of workflow, and I provided you a simplified diagram which outlined each of the important steps in your workflow this semester. However, now that you've developed more technical skills around capture, I will give you a more complex diagram for your workflow. I will suggest to you that this workflow begins at pre-capture through to capture, input processing, and then final destination, which will be defined by what type of output file you need to produce. So at pre-capture, it's about the observation and the evaluation of light. So remember I said to you very early in the semester that capture begins even before the camera is set up. That is, at the observation of light, the lighting scenario. You've had some great lectures which cover the physical quality of light and the use of filters to color correction and management of light quality and strength. So now you should be developing a sense of what light is, its quality, strength, color, and how the direction and type of light changes the aesthetic of the image captured. At raw capture is where you have to set the camera for the prevailing lighting conditions. You are asked to think about the exposure settings, dynamic range of the capture device, your camera, and to analyze the subject brightness range of the scene, that is, the tonal range from the brightest to the darkest tone of the scene before your camera. Observing the light and understanding how you would like the scene rendered defines how you will set up the image capture, the exposure. Recognizing the dynamic range of your capture device, the camera, and identifying the overall subject brightness range impacts directly on the capture exposure settings used. So your dynamic range, the capability and the capacity for your camera to capture what range of tonality within the subject brightness range. Exposure is measured through the reading of histograms, and you have developed an understanding of bit depth. But the subject brightness range, the difference between the highlight shadow and the shadow information, and how many steps of tone in between. In the past few weeks in class, we've been working with input processing. We visited the concept of the creation of a digital master file or negative. Input processing, remember, is replacing all the automated processing that happens in camera when you photograph to capture in a JPEG format. When you photograph to capture raw data, the input processing has to be completed by you. This provides you with full creative control over the final look of the image, which is good. It's a positive thing. But today I'd like to talk to you more about setting up your workspace, the monitor calibration, and choosing correct color space, and thinking about how you're going to know the output usage of your image. How to set your parameters for outputting the image from raw processing software, Adobe Camera Raw, is fully dependent on what you're wanting to do with the final image. Step 1, now let's revisit this workflow model. So step 1 of the workflow model was for you to become proficient in using Adobe Bridge to import your files from camera or card. And Adobe Bridge is a really powerful software interface between the camera and input processing software Adobe Camera Raw. But it's in Adobe Bridge that you're able to sort and rate your files, apply metadata information, and maybe output a contact sheet or a web gallery for future reference. And also it's where you can open your files for input processing directly from Bridge to Adobe Camera Raw. Always remember to use Adobe Bridge as a first step in your input process. Adobe Camera Raw is the tool we are using this semester to create a digital master file, the base point for your output process. in Adobe Camera Raw, you've had the opportunity to practice applying parametric or global changes to a single or multiple images, as well as using the adjustment brush for localized changes. You also have learned how to apply sharpening and to crop your images without making permanent changes. At this point, you can choose to save your image as a raw file, that is a DNG, or a pixel-based file format. What file format you will save your image as? Now, this depends entirely on how you're going to use the file as a next step, either in post-production or just to output. If you're going to continue to work with this file, either preparing it for print, then saving to a PSD or a TIFF file format is a correct way to handle the output. Why? Well, you need to retain that 16-bit pixel depth of the file. If you save it as a JPEG, then it will automatically be downsized to an 8-bit pixel depth file. If you are just wanting to upload your image to social media or send it an email, then a JPEG is adequate. Remember, when you save from your digital master file, this original file is not overwritten. The JPEG, TIFF or PSD file, or the DNG file for that matter, is a copy of the master file. If you have multiple raw input processes from a single file, such as monochrome, split tone, color, then you can save these as DNG files. Just remember to change the file name to indicate what type of input process has been applied. This makes the creative process much more automated and efficient. You can then save pixel-based images from any of these selected DNG options. So what I'm saying is, before you decide to output your file, you have to decide whether it's going to print, if it's going to be used as a screen-based image. So each of these options, to print, to web, to television or projection, have different output requirements. So when you're thinking about image output, there's some important decisions to be made. These decisions are based on how the image will be used. It determines the selection of color space and bit depth, the image size, how much sharpening is applied, and all those parameters depend on the destination or the use image, whether for print, projection, web or television. Each of them has a specific set of requirements. From Adobe Camera Raw, you can save an 8-bit or 16-bit file at DNG, TIFF, PSD, Photoshop file or JPEG formats. In Adobe Camera Raw, in the Workflow Options interface, there's a series of prompts that ask you to set up the output color space, bit depth, size and sharpening. It also allows you to open the image directly into Adobe Photoshop as a smart object if you're working with web-based images. The Save As interface asks you to select a destination. So where do you want to save the file? It allows you to set up new folders. It asks you to this is where you'll change your file naming here. It asks you what format that you want to output, and if you're outputting as a JPEG, what size. There's an option again to change your color space and image size and apply some preset sharpening here. So in the Save As interface, asks you your destination. Do you want to change your file name? This is your file format, not up here. Okay, your color space, image sizing and output sharpening. So what file format? It absolutely depends on whether you're going to continue to work the image. Is it a base image for a composited composition? Are you going to prepare it for print? Do you want to send it as an email, or you just want to save it as a DNG for later reference? So when thinking about the fundamentals of digital output, it's absolutely necessary to identify what the image output destination is. What's its usage and what production medium are you going to use? So what I'm referring to is whether the image will be printed or whether it be used as a screen-based image. This subject primarily looks at the output to print using photographic paper in a professional Epson inkjet printer. However, the information regarding output for magazine or newsprint or as well as large signage will be included, as well as a number of different print output options. So when you're thinking about printing your image, what type of substrate that you're going to print on. Each of these as well will require some different work. When you decide to print your image, you will need to know what the device is that will provide the service, and each device has specialized output requirements. These may be broken down to some categories such as offset printing and pre-press production, dye sublimation, digital halftone, digital chromogenic, and inkjet printing. So if you're sending your image for offset or pre-press production, so that's commercial high output print process, which is can be found in magazine, book and newspaper printing industry, you need to prepare your file and output your file as a CMYK file format at 300 ppi. Newsprint is different to this. Newsprint will only require a 150 to 200 ppi resolution file. Why? Because it's a lower resolution output. 2 levels of magenta and also 2 levels of cyan. So what am I saying? I'm saying that the ink sets provide a finer quality of reproduction of your digital image from screen to print. So let's just have a look quickly at some printer and image resolution terminology. PPI refers to pixels per inch, and I'm sure you know this already, and it's a measurement of digital file linear pixel resolution. Okay. The higher the PPI, the more pixels that make up the image. DPI refers to dots per inch, and it describes the size or the number of dots per linear inch that a printer can produce. The finer the dot, and the more dots per linear inch, the more detail and the less banding will appear on the printed image. So, when we think about the Epson 3880 being able to print at 2880 DPI and have that correlation to more detail and less banding in the printed image. So it's a higher quality, higher resolution image that it's printing. So when you're thinking about printing your work, ask yourself some questions. Who'll be printing the images? Is it you, or you're going to output to a third-party print service? What type of substrate or material will the images be printed on? And also, what is the final size the images? So is it just going to be a small 20 by 25 centimetre, or do you want a large wall size print? The answers to these questions will then define what resolution the image must be set to and how much or what type of output sharpening must be applied. It also then defines the output color space. Some print processes, as you've seen, require a CMYK output rather than RGB model that we work with. If in doubt, then ask these questions of the print bureau. But remember, it's absolutely necessary to work on a calibrated monitor in a stable and suitably lit workspace. Let's have a look at what I mean. So let's get into some detail around the technical concepts of digital image output starting at monitor calibration. But before I do that, please check that your monitor is set correctly. That is, your monitor color space is set to either Adobe RGB or ProPhoto or sRGB or CMYK, depending on, remember, the destination of the image. What's monitor calibration? And I believe Glenn's been over this already. It's a process of setting the monitor to display correct brightness, contrast, white point and color. It's the only way you can ensure that the images that you're working on will output successfully. If you're working on a monitor which displays your image either too dark or too light, then the resulted printed image will not match the on-screen representation. So having your monitor calibrated provides you with the confidence to know that what you're seeing is correct color and tone. Calibrating your monitor allows the RGB profiles to be displayed in a correct manner. These profiles are defined by the white point and the red, green, blue primary colors. These profiles describe an additive color space. So here I've provided you with some guidelines for setting the calibration of your monitor when you actually get around to do it. But before I proceed, I'd like to say that not all monitors are capable of being calibrated. Here at JCU we use the Apple Max as an industry standard, as the monitors are suitable to be calibrated, and they are also quite a stable monitor. I do the monitors once every 6 months, and I find that there's very little shift from calibration to calibration. To replace this this iMac or the Mac monitor with another brand is sometimes double or triple the price of our Mac monitors. You can use a device such as Spider, X-Rite, Color Monkey or Color Eyes to profile. And these devices are used to create a display profile which includes setting up the color temperature, tonal reproduction, luminance of the display or the screen. When calibrating your monitor, you should take some environmental variance into account, such as ambient light and how much light flare is falling onto your computer screen. The room you do your editing in should have static ambient light and color temperature. What do I mean? So if you have a window in the room, then always pull the blind down before you begin. As the day moves on, the amount of light and the color temperature of the light will change. This will affect how you see and assess your on-screen images. Also ensure that any room lighting does not create light flare on the screen. If you can see a reflection on the light of the light, then move the computer and or the desk until this disappears. Be aware of how color is reflected from surfaces, including clothing, to the screen when editing. The work environment should be color neutral, and if you're serious, you will have a workspace with neutral grey walls with no more than 60% reflectance value. Your clothing should be the same, although as a rule I just wear black when working on my computer and editing. So let's look at some key terms you should know when talking about screen, that is monitor calibration. Color gamut refers to the levels of color your monitor can display. In the system preferences, you can set the monitor working space. As you can see, I have my monitor set to RGB 1998. This defines how many levels of color my monitor can display. Color space describes how the colors are organized within the display. It defines what levels of each specific color and tone may be represented. So here we're looking at the ProPhoto, Adobe RGB, sRGB and CMYK color spaces. The large horseshoe shape at the back is visible color. Ensure that you have selected the correct color space for output in the Output Workflow options in Adobe Camera Raw. So it's no use outputting to Adobe RGB if you're sending it to pre-press. You need to go down and find your generic CMYK profile. Here it is. If you look at the background image, the large horseshoe shape represents visible color. Okay, there it is in the background there. This is the color visible to the naked eye. This is our color spectrum. If you then look at the first large triangle named ProPhoto RGB, you'll see that this color space can display color even beyond what we can see. Can you see the elongated green and blue color? So the blues and the greens represented, or the ability to represent those colors. The next largest color space is Adobe RGB, and this is my default. If I'm working with landscape images primarily consisting of greens and blues, vibrant greens and blues, then the ProPhoto color space would be much better as my default. So as you can see, the RGB color spaces can only display some of the visible color. The problem here is that what we see through the camera may be a little bit different to what we see on the screen. This color space is suitable for portrait work, great for portrait work, and great for most landscape work. But when you have those vibrant deep blue skies, in the middle of winter that we see up here in North Queensland, that's those color here in ProPhoto. But they're still represented adequately in Adobe RGB. Let's have a look at sRGB. So think about sRGB color space. Now this is television and web, so it's a much smaller color space. And if you think about this center area here, so it's going to display adequately most color on screen. Even smaller is the CMYK working space. The big picture here though is if you're always working for CMYK output, then the color display you're working on should be set appropriately. Otherwise, you'd need to be very careful with color conversion all the time. When you're calibrating your monitor, ensure that you've chosen the correct color space. In this image here, what we're seeing is the visible color space, okay, once again that large horseshoe shape, and what color Epson 3880 can print. So the correlation between the output with the Epson 3880 and the Adobe RGB color space is, no, they're quite similar output and color spaces. So when you look at this slide, you can begin to understand the correlation between color gamut and output. You need to know what the color gamut of the output printing device has, and then define the output color space accordingly. What you're looking at currently is Adobe RGB color space and Epson 3880 output, the color space or the gamut for 3880 exhibition fiber paper, which is like a luster paper. It's not quite as glossy as a semi-gloss which you'll be using. Adobe RGB color space and what the Epson 3880 can reproduce is defined here quite beautifully. So the Adobe RGB color space is the color wireframe, and the Epson 3880 fiber is a white wireframe. So you can see that the Adobe RGB maps beautifully within Epson 3880 printer gamut and profile. So let's have a look at the ProPhoto color space as represented by the white color frame, and what can be reproduced by the Epson 3880 printer on the same exhibition fiber paper. So looking at the ProPhoto, which is a white color frame, which is much larger than what can be represented on paper, which is the Epson 3880 exhibition fiber paper. Like I said, it's like a luster paper. As you can see, the ProPhoto color space is much larger than what can be reproduced. Next week when we begin to print, I'll introduce you to strategies which you will be able you can use to map this color space either up from Adobe RGB to Epson 3880 output, or down from ProPhoto to Epson 3880 output. So what you can see on your monitor at times is just a little bit different to what can be printed. And when I talk to you about images being in and out of gamut, this is what I'm talking about. What we're seeing in Adobe RGB color space, what's in and out of gamut, what is reproducible from Adobe RGB to Epson 3880, and what's in and out of gamut, what can be reproduced from the ProPhoto, what we're seeing on color space, what we're seeing on our screen, and to the Epson 3880 are two different things. With one single photograph, I just want you to see how the histogram changes. So watch the histogram up in the top right hand corner as I alter the color space of the image. Please note how the color and the tone is represented in the histogram. So here, if you look at the histogram, and let's have a look. This is with my color space set at Adobe RGB 1998 at 16 bits channels, sRGB, ProPhoto, CMYK, and US Newsprint. So you can see how each of those profiles limits or changes how the color and tone is represented or mapped in your image. So before calibrating your screen, ensure that your computer screen is set to the correct color space. So you're going to go to Edit, down here to Color Settings, which will bring up this dialog box, and I just want you to follow these instructions. So next week in class we look at calibrating monitors, and setting your color space on your machine.